So this novel innovation that made Webb possible is exactly why NASA and why humanity continues to push the envelope, as the test pilots say. Push the edge of the envelope. NASA's no stranger to first steps, and as we enter this new era of spaceflight and discovery, we need to be bold. We have to take risk, but the reward is worth the risk. And this is proof of that. It represents the largest international space science program. It collaborates internationally. Now, Michelle, I'm going to turn it back over to you to share messages from our international partners.
Thank you so much, Minister. The mission would not be as successful as it is today without the teamwork and contributions from our mission partners, the European Space Agency and the Canadian Space Agency. We are pleased to share with you a special video message from ESA's Director General, Dr. Joseph Aschbacher, and their Director of Science, Gunther Hasinga.
The James Webb Space Telescope is such a fantastic opportunity. It's a once-in-a-lifetime opportunity which we have here, and we are so excited, both Günther and myself, on this first data release. It will really change the understanding of our universe. But before I hand over to Günther, just one word. This is also a symbol of international cooperation. The partnership we have with NASA is outstanding. It's really exciting, but really fantastic, and also with CSA, the Canadian Space Agency, and this is more than science, it's also a symbol of international partnership. But Günther, a bit more about the James Webb Space Telescope, what this means.
Thank you very much, Joseph. Yeah, this is the day that we have all been waiting for so long, and now it's happening. You know, James Webb is a fantastic machine, and its infrared eyes are 3 times sharper than the Hubble Space Telescope, and they are 100 times more sensitive. So with these infrared eyes, you can peer into dark, obscured regions in our universe. You can look at the very first phases of the universe after the Big Bang. You can look at planets in our own solar system and in around other stars. And it is indeed a once-in-a-lifetime chance, almost like the moon landing for astronomy. And it will actually feed a whole new generation of scientists, and this will continue. It's a masterpiece for international cooperation, as Joseph had said. We are working with NASA and the Canadian Space Agency, and this is actually in tradition to Hubble, to Cassini-Huygens, where NASA is leading and ESA is partnering. But we are also opposite, having missions where ESA is leading and NASA is partnering, like for instance Bepi Colombo JUICE, the Euclid spacecraft, and so on. So ESA, the science program, is actually enabling the European scientists to lead in a number of discrete fields, and one of the important fields is, for instance, astrometry with Gaia, where we are really having a leadership position. And now James Webb. James Webb will answer a lot of questions, even some questions which we do not even know about yet.
Talking of NASA and what we do here, I mean, of course, we have many contributions in the James Webb Space Telescope. We have instruments, 1.5 instruments that we are providing. We have a science team that is working with NASA and the other partners. But one event was very special, and which was the launch of the James Webb on Christmas Day from Kourou on Ariane 5, and this was really a very important event for us. Not only is NASA entrusting this James Webb Space Telescope to us, of ESA, but also the insertion of the James Webb Space Telescope into orbit was so precise that scientists have a much longer lifetime of the James Webb Space Telescope, actually doubled the lifetime, and this is really fantastic because this really shows also that our space transportation technology, in addition to the science technology, is just outstanding, and very proud and very happy about that.
So go Webb, go!
Go Webb, go!
Our next video is from the Canadian Space Agency, and this is from the President, Lisa Campbell.
Hello, everyone. Today marks a major milestone in the Webb Space Telescope mission, as we're about to witness Webb's unprecedented view of the universe. Webb promises to be the next giant leap in space astronomy. We're confident that the observatory will exceed expectations. Bold, important missions like this are only possible through strong international collaboration. This one-of-a-kind mission is a testament to what we can achieve when we work together, and Webb is truly a global effort. Congratulations to our partners, NASA and the European Space Agency. Thousands of brilliant minds around the world are behind the design, launch, and operation of this complex space telescope. The Canadian Space Agency is honored to be part of Webb. Canadian specialists across industry and academia united their efforts to provide our instruments. Canada's fine guidance sensor will keep Webb perfectly aligned during all of its observations. And the nearest instrument will observe the earliest galaxies and perform in-depth analysis of the most promising exoplanets. For the science community in Canada and across the world, having access to data collected by Webb will lead to unexpected discoveries. Webb will not only help us work out long-awaited answers to age-old questions, it will also inspire new, cutting-edge research that leads the way to our cosmic origins. Congratulations to all who made these imminent discoveries possible.
If it wasn't for years of steadfast congressional support, this extraordinary project wouldn't have been able to get off the ground. So it's fitting that we have representatives from Team Merlin joining us. And let me clarify, these gentlemen are not just representatives. They are friends of NASA Goddard. Please join me in welcoming Maryland's 5th Congressional District Majority Leader of the United States House of Representatives, Steny Hoyer, Senator Ben Cardin, Senator Chris Van Hollen, and the Representative Trone from Maryland's, David Trone from Maryland's 6th Congressional District.
Thank you very much, Michelle. It's good to be here with astronaut Nelson. So sorry you're sick, Andrew. All of us have fought. Hubble was at risk. Goddard was at risk. Webb was at risk. This day gives a new meaning to as far as the eye can see. The vision of the world is greater today than it was yesterday. And it will redound to the benefit of all the peoples of this earth. What a wonderful day. I want all of you who have worked on this project to stand up. Stand up. All right, you're using our time. America thanks you, and the world community thanks you. Our time is short. Let me yield to the senior senator from Maryland, my dear friend Ben Cardin, who has fought so hard, along with Barbara Mikulski, to make this day happen.
Thank you, Steny. First, excited. This event is out of this world. How many times have I said that? I can really mean it this time. We are so proud of the role that Maryland has played. You heard Michelle mention all the different organizations and government agencies and institutions and private. So many of them are located in Maryland. Steny already acknowledged the incredible workforce. We know the 20th century will be known for space exploration by Neil Armstrong's steps on the moon. The 21st century will be led by the work done by the James Webb Telescope. This is an incredible moment. It's now back to the future, and we're going to be part of it.
Chris Van Hollen.
Well, it's great to be back here at Goddard, and thank all of you who have been part of this team. You know you've made it when you have your own cheerleading squad. As somebody who was briefly a physics major but bailed out after quantum mechanics, I want to thank all the scientists and the engineers and everybody who stuck with it to bring us to this brilliant day. This is a great day for humanity, peering further back into time, deeper into our universe, answering some questions that are fundamental to who we are and how we got here. Thank all of you from around the world, because this was an international endeavor. And while there were bumps along the way, once the launch happened, everything had to go perfectly. And it did because of all of you. I do want to say Maryland is proud, at least on this day, to be the center of the universe. And thank you. Thank you to Goddard. Thank you to the Space Telescope. And we're going to continue to invest in this mission and so many others, along with my friend David Trone, who's also on the Appropriations Committee in the House of Representatives.
So thank you all very much for this incredible moment in scientific history. And space exploration is what connects us all. And that's what's so fantastic about it. As the saying goes, if you want to go fast, go alone.
5.
But if you want to go far, go together. And this team has gone together. So thank you and congrats.
This telescope is by far the largest science endeavor NASA has ever undertaken, and it required a huge network of companies from around the world to build it. Northrop Grumman led that team and helped NASA and its European and Canadian partners to achieve the success we see today. To help celebrate that success, we have a special message from Northrop Grumman CEO, Kathy Warden.
On behalf of the entire Northrop Grumman team, congratulations to the space and science communities around the world on what will be the first of many exciting and truly historic Webb missions to come. These incredible images, never before seen by humankind, carry us further than we've ever gone before, and we're just getting started. The extraordinary telescope represents a new era in human discovery, and equally important, it represents the engineers, technicians, scientists, and the countless other teams that have come together to define possible. Our work, the technology we've created, and the images it captures will inspire the next generation of thinkers, innovators, and problem solvers. This is the true legacy of Webb. Thank you, and congratulations.
As I said before, it took companies from around the world to get Webb in space. Right now, we're going to hear from the CEO of Ariane Space, Stefan Israel, with a message he would like to share with you.
Webb, an incredible adventure we at Ariane Space were honored to be part of. A 20 years collective challenge that finally brought us together in Kourou with Dr. Z, Greg Robinson, Joseph Aschbacher, Daniel Nunschwander, and Philippe Baptiste on a Christmas morning we'll never forget. 27 minutes and 11 seconds, which will be among the most important of our lives. After a perfect launch with our Ariane 5, which has doubled the Webb lifespan, and such a long journey, we are now on the verge of discovering images that will revolutionize our understanding of the universe. A game changer created by the collective work of passionate and brilliant people from USA, Europe, and Canada. To these dedicated teams, I want to say thank you. Thank you for your trust in Ariane that made this incredible adventure possible. Go Webb.
All right, guys. We're only a few minutes away from seeing the first images, but before that, I would be remiss if we didn't take an opportunity to let those that led the way have an opportunity to say a few things. We have the Webb Program Director, Greg Robinson, Northrop Grumman's Webb Program Manager, Scott Willoughby, and last but certainly not least, the Webb Project Manager, Bill Oakes.
I didn't get to tell the helicopter, so I'll just wing it. So I will say, when I came up the stairs, by the time I got to the top, I wanted to throw off the jacket and run out to the 50-yard line. So thank you for that welcome. I don't know what I would have done when I got there. So who did not see that image yesterday? Well, as the old saying goes, you ain't seen nothing yet. Just hang around a little bit longer. I just want to do a couple of quick thank yous. You've heard from most of them. Thanks to the entire team, certainly the Goddard-led project team, Northrop Space Telescope Science Institute, and our international partners. Also, I want to thank, I call it the ninth floor, the NASA administrator and his team, and the White House and Congress. All of us are part of this, and when I say team, I mean everyone from beginning to end. And we all had to be aligned to make this happen, as Thomas often reminds me. So thanks for all of that. I want to do a couple of special thanks. Special thanks to Scott Willoughby for leading the team out at Northrop, Bill Oakes for leading the overall team, and I know both of them will say more about their teams and the capability of the spacecraft. And a special thank you to Thomas. I often say, twisting both of my arms to get me to take over this, to be part of this incredibly smart and resilient team. So thank you, and thanks for coming.
Thank you. It's humbling to be here at Goddard. My team from Northrop Grumman spent a lot of time here and at many of the NASA centers and other places around this country. But this is where relationships were forged, and it's relationships that built the James Webb Space Telescope. And it's been a common theme here for a purpose, right? The international relationships, the government industry relationships, but the relationships that are dearest to me are the ones that took place on the floors of the high bays and in the meeting rooms and debating hard problems. And sometimes those answers weren't certain as much as engineering wants to be, and you're using judgment and people's guts and brilliance to make decisions that led to perfection. And what Bill and I did throughout all of this was really kind of singular. It was giving that team power. And I just kind of leave with a phrase that I used back when we were getting into the final build of Webb, when people were putting this together, that every human who touched this for the last time should know you get that privilege. And you get to bring your pride to the floor to do that. But you have to check your ego, because pride is powerful. But somebody's going to ask you a question, did you do it right? And somebody's going to look at a picture when you did it and see, was it right? And somebody else was going to review that and stamp that it was right. And every single person mattered in that. And in the end, it was perfect. So thank you. And working with Bill was really a relationship that's going to last a lifetime, over a decade. I think we broke the record for industry-government partnership. We're not supposed to be together for 10 years, but we were. Bill.
Thank you. Well, I guess I'm the cleanup, typical job for a project manager. First, just a little update on the observatory. Over the weekend, we finished the last commissioning activity, so we are officially done with commissioning. We have an observatory that is in excellent shape, that either meets or exceeds requirements. And as mentioned earlier, we have 20-plus years of fuel on board. And finally, we have actually started our first year of normal science operations, and that is now in full swing. So, as the old saying goes, it takes a village. Well, with Webb, it actually took a town of about 20,000 people over a period of 20-plus years across 29 U.S. states and 14 countries. And even more, if you add to that number the family, the friends, the significant others, et cetera, who supported Webb, they are also part of that Webb team. You cannot really single out any one person for the success of Webb, but everyone here should know that as they see each image, you are a part of that image. We would not be successful without your contributions to the Webb program. When I see these images, I see four things. I see dedication, and I have never seen dedication on this project like I have seen on any other mission I have worked. I see personal sacrifice of so many individuals that my heart is just overwhelmed with pride for the folks on this program. Finally, also I see passion. I've never seen the passion for this program, and that's what helps with the first two things I mentioned. Finally, I just see the faces of all our individuals who have worked on this program, both the past and the present. and neither myself nor NASA will ever be able to thank these persons enough. And finally, on a more personal note, the Webb team itself, we are all going to be bonded for the rest of our lives by the Webb experience. And I have to thank you for the privilege that you have allowed me to be part of that experience. Thank you.
Thank you. All right. Thank you and congratulations, gentlemen. And congratulations to all of you once again. Today, we celebrate you and your achievements. Now, listen, I'm sure you're excited to see exactly what Webb will show us. So here's the plan. We're going to take a quick break, but as you all at home can see the countdown clock, we're literally minutes away from the reveal. Are you all still excited? It has been my absolute pleasure spending this time with you. We can't wait to share what humankind is capable of, and we are just getting started. Let's enjoy this journey. Now, on the count of 3, I want you all to scream, "Go Webb." 1, 2, 3. Go Webb!
Skywatchers, this is it. This is the day we get the first science images back from the James Webb Space Telescope, and you've got a front row seat to the cosmos. I'm Michelle Thaler, your host for what can only be described as a celebration for everyone on Earth. So think about this. Light from the earliest days of the universe has been traveling to us for billions of years. Just over the last few weeks, we've captured some of that light with a telescope that sees the universe in an entirely new way. And today we share the very first results. So longtime space fans are going to know who this is. This is Dr. John Mather. He's the senior project scientist for the Webb Telescope and a Nobel Prize winner. And John, I couldn't be happier to be here with you today.
Thank you. It's a thrill to be here for this very special day.
How are you feeling?
I am thrilled and I'm relieved because you know when you start something this big, you know there's always a possibility it might not work. It did work. We are so proud.
And you've been on this project for a very long time, right?
Yeah, started in 1995. We had just finished measuring the Big Bang. We measured it with a Cosmic Background Explorer satellite that we built right here at Goddard. And we measured the spectrum. We measured there are hot and cold spots in the Big Bang. So we said, now we know it all, how it all got started. But then what happened after that? So then I got a call from NASA headquarters. Would I like to work on this new telescope that's going to help answer those questions? What happened after the Big Bang? How did the galaxies grow? How did the first black holes grow? What happened all the way from there to here? So this is our time machine, and I just wanted to be part of it. I am so thrilled that we got a chance to do it.
One of the things that I remember you saying, and this is kind of amazing, that after you win the Nobel Prize, you thought that this mission was the most important thing to work on.
Absolutely. It's the next question. After you know how it started, what happened then? And you know, suddenly we now have the technology to do it. We didn't have 50 years ago. We didn't have the technology 25 years ago, even when we started this. We had to invent things along the way, so we did that, and here it is.
Well, thank you. We'll be back to you in just a moment. So at the moment, we're going to talk about the way that Webb is a completely new way to explore the universe. So today, the mission releases its first science images and gives wings to the dreams of so many people who worked so hard for so long to make this possible. For everyone on Earth, this is your telescope. This is the largest, most powerful observatory ever put into space. It's the product of thousands of people working for more than 2 decades. This is a mission that's singularly focused on the biggest questions in science. So the following phrase is often used too easily, but today actually does mark the dawn of a new era. Today, the Webb mission is open for scientific business, and this is just the beginning. The best is yet to come. So, John, one of the things you told me about is that you really want to make sure there are some people that get thanked, people that put a huge amount of effort into this.
Absolutely. Our current project manager, Bill Oakes, took the project from a time of trouble when we didn't exactly know how we were going to get this to work, and got it all the way to the end. Here it is working, and it's because of Bill made this worldwide team. 20,000 people around the world were involved in making this thing all work, and Bill has been there every day making sure that it would happen. So other special person is Senator Barbara Mikulski. She saved our telescope, and she saved the telescope before us. She made sure after the Hubble telescope was launched and it was not in focus that we would go up and fix it. She made sure that happened. When the Webb telescope needed more resources, she made sure we could get that. So Barbara, we thank you.
Well, it is such an honor to be with you, Jay. I mean, it's been a pleasure to be working with you through this whole thing. Thank you so much. Congratulations, and go Webb.
Thank you.
So this broadcast, much like every part of this mission, is a partnership. On our journey to explore distant places in space, we've been joined by intrepid travelers from around the globe. We have so many extraordinary collaborators. So let's check in with our partners who will be sharing the stage with us today as we reveal Webb's 5 first science images. From the European Space Agency, I'm joined by Katie Haswell in Darmstadt, Germany. Katie. I see Katie in the background there. Also joining us from the Canadian Space Agency in Montreal, we have Natalie Willette and Sarah Gallagher. Bonjour. I see Katie in the background there. I see the waving too. And so naturally, we're also going to be visiting the nerve center of this mission, the Space Telescope Science Institute on the campus of Johns Hopkins University in Baltimore, Maryland. And there we have Alex Lockwood and Carl Gordon, and they're going to give us updates and more. Good morning. Great. So we'll be back with our international partners shortly, where they'll each reveal one of the new images. But today we're also going to be joined by millions of science fans from around the world. Many are gathered at watch parties just for this event. So here we are really going international. So I'm beginning with Bhopal, India. Do we have a signal from Bhopal? Yes. Excellent. Welcome to NASA. Hello, everybody there. Wonderful to be talking to you today, all the way in India. We'll be back to them later, yes? Great to wave to you. Hi, wonderful. And we also have a warm welcome now in Portland, Oregon. So we have the feed from Portland. A bit dark, but I see everybody there. Hello, Portland. They're in an auditorium, I see. Okay, next we're going to go off to Milan, Italy. So afternoon in Italy. Do we have the feed from Italy? I guess we have a screen from Italy. And next we're going to go to Rutland, Vermont. So is this Vermont? Hello, Vermont. Hi, everybody. Nice to see you. Thank you for being part of this today. Okay, going even a little bit further afield, we have Netanya, Israel. Hello. Hello, Israel. Yay. Really nice to see you guys. Okay, and just one more for now. I see people like giving me hugs. Okay, we also have Vancouver, Canada. Hey, Vancouver. Hi. All right. Wonderful. Wonderful to have all these people with you. So right across from the campus from me, there's also a huge watch party taking place with members of the Webb team. So the wonderful thing is that they actually are people that have worked on the mission, and they are part of our NASA Funny family. So hello Webb team. There they are. Yes. A lot of people I recognize there. So it's incredibly important to me personally, and also to all of us at NASA, that the universe belongs to everyone. And we are thrilled to share this day with fans everywhere around the world. We'll say hello to some more later in our broadcast. So now it's time to start the main event. What you'll see over the next hour will be a collection of images newly processed by the Webb science team. Only a tiny handful of experts have seen the images so far, and I can tell you that we have been so excited to unwrap them for everyone. We will be releasing each image in turn in real time. As soon as you see it on this broadcast, it will be available for download on the internet. On the screen below, you can see a timeline showing where we are in the show and what's coming up next. And by the end of the show, all 5 images will be available to everyone. So hopefully you can tell I'm excited. Okay, so let's do this. Okay, we're going to release the first image right here at NASA Goddard Space Flight Center, Maryland, and we're just outside of Washington, D.C. NASA Goddard is home to the project office of the Webb Telescope, and the observatory portion of the telescope, the mirrors and the science instruments, were integrated and tested here before launch. So for many of us, including myself, seeing Webb come together bit by bit right in front of our eyes was an emotional and very inspiring experience. So it's kind of like a part of us was out there with Webb right now. 1 million miles away, part of our hopes and dreams are out there. So I'm joined now by Jane Rigby, the operations project scientist for the Webb mission. And she's a familiar face for people who've been following this before, so welcome, Jane.
Hi, Michelle.
Okay, so Jane, you not only get the honor of revealing the first image, but this actually got a little bit of a sneak preview. I understand there was a very select audience who's already seen the image.
Yes, so last night, on behalf of the project, I had the privilege of traveling to the White House with the NASA Administrator Nelson and other senior staff to share our first image with President Biden and Vice President Harris. And it was really fun. Oh my gosh. They really geeked out. We had a closed-door session where we got to walk through all the images and just share the excitement, and they were so thrilled, and they got the profundity of what we're seeing. And so now we're gonna let's do it.
Okay, we've got the whole world watching. Are you ready to put the first image up?
Oh, let's do it.
Absolutely. All right, here we go.
Okay, so the first image is a deep field, and it's also a deep field with a cluster. So why don't we walk through this just a little bit? So if we come up and look at this image, first of all, it's really gorgeous, and it's teeming with galaxies. And that's something that has been true for every image we've gotten with Webb. We can't take blank sky. Everywhere we look, there's galaxies everywhere. And so, this image, as we're looking at it, what we're seeing is not just all the galaxies, but there's a cluster here. And so the cluster are all these white, kind of ethereal galaxies. We're seeing them as they looked back in time. right? The speed of light is only so fast. And so as we're seeing distant galaxies out in space, we're seeing them as they looked billions of years ago. So these cluster galaxies, the white ones, we're seeing as they looked about the time the sun and the earth formed. And then behind the cluster, we have the gravity of the cluster is distorting and warping our view of what's behind. And so there are these galaxies that look stretched and pulled, kind of like they've been magnified because they've been magnified by the gravity of the cluster, just like Einstein said they would. And it's really, there's so much detail here. We're seeing these galaxies in a way that we've never been able to see before. There's just a sharpness and a clarity we've never had. And so we can look at, if we zoom in on this image, and I encourage you as you grab this image at home, zoom in. You can really zoom in and play around. There are galaxies here in which you're seeing individual clusters of stars forming, popping up just like popcorn. And then we also see in the background of this image, kind of littered like jewels all over the back of the image are these faint red galaxies. Now, that was what we built the telescope to do. The most distant of those are billions of years. We're seeing as they looked more than 13 billion years ago. And so galaxies like that one right there, this little red guy, you're like, okay, yep, what is that? Well, Webb got spectra to figure out what those galaxies are made of, and this is that one. We're seeing as it looked 13.1 billion years in the past, less than a billion years after the Big Bang. And we're seeing the elements of oxygen and hydrogen as well as neon. This is how the oxygen in our bodies was made in stars, in galaxies, and we're seeing that process get started.
Yeah, I want to give this a little bit of context. So this is now the farthest away galaxy that we have this sort of detailed information about.
That we know what it's made of.
We know what it's made of.
Yes.
And this was not a long exposure for Webb.
No, the previous record holder, right, the Hubble Extreme Deep Field, was 2 weeks of continuous work with Hubble, and it was just imaging. With Webb, we took that image before breakfast. The amazing thing about Webb is the speed at which we can churn out discoveries. So everything that you're going to see here in this broadcast is a week, and we're going to be doing discoveries like this every week.
That is absolutely incredible, Jane. So thank you so much for joining us. It's been an honor to be working with you. Congratulations on all your hard work.
Thank you. It's so wonderful to see it pay off.
So thank you, and I'll see you later on today, I hope. So
yes.
Enjoy the day.
Thank you.
Right. So from distant galaxies, we now turn our eye to something a bit closer. It's a planet, but not one in our solar system. Remember that Earth and its sibling planets aren't the only show in the universe. When scientists and engineers started developing JWST, the search for exoplanets wasn't even part of the plan. That's changed. Exploring exoplanets is now a major component of the mission and the subject of our second big reveal of the day. I'm going to send it now to our friends Natalie Willette and Sarah Gallagher at the Canadian Space Agency in Montreal. So again, bonjour. I guess we're having a little...
Okay. I'm Nicole Malone, and I'm here to tell you...
Sorry for the brief pause there. We're now going over to Canada. Okay. Yep, we're all ready. Yeah. Okay, I apologize. We're having some trouble with the signal from Canada. But luckily for us, we have an exoplanet expert right here, just in case that happened. So this is Nicole Colon, and she's an exoplanet scientist at NASA. And we're going to talk about this amazing new result from a very hot planet, I understand about 1,000 light years away.
That's right. The exoplanet is named WASP-96b, and it is this hot, gaseous, giant, puffy planet that it is about 1,000 light years away. So that's why today's release is so exciting, because it teases at what Webb is able to do for such a distant planet.
Absolutely. So talk us through what this discovery is and why this is so significant.
Mm-hmm. Well, this reveal that you're going to see is going to show the first spectrum of an exoplanet as taken from the Webb telescope. And this is exciting because it covers infrared wavelengths of light that we have not had access to before. So we've been able to use other telescopes to explore exoplanet atmospheres in the infrared, but not to this level of detail. And this is just one sliver of data that Webb is providing us using the nearest instrument specifically.
And there's something about infrared that is actually particularly good for the spectrum. So in this case, what we're doing is we're actually going to take the light and break it up into a rainbow and look very, very carefully at how much color is coming in each part of the spectrum. So I believe we have that image, if we can put that up.
Okay, yes, I believe we're revealing the spectrum right here. So we now have our spectrum, and this is exactly what you're seeing. As you just described with spectroscopy, what we did was we observed a transit of an exoplanet. We observed the planet as it passed in front of the star. Now, mind you, this is not a direct image. This is an indirect image. So we've seen the effect of what happens when the planet and its atmosphere passes in front of the star. The starlight filters through the atmosphere, and then you can break that down into wavelengths of light, and you get a bunch of what looks like bumps and wiggles to some people, but it's actually full of information content. So you're actually seeing bumps and wiggles that indicate the presence of water vapor in the atmosphere of this exoplanet.
So we have the spectrum up here. Is there anything you'd like to highlight particularly?
Yeah, absolutely. So we have several features marked here. So I call them features. They're these, what I just referred to as bumps and wiggles. But what you're seeing here is a telltale signature, the chemical fingerprint of water vapor in these atmospheres, in the atmosphere of this specific exoplanet. And the other thing we can tell actually is that there's evidence of clouds and hazes because the water features are not quite as large as we predicted. So we can take that and infer that there are presence of clouds and hazes.
Right. Now, one thing that we really want to make sure people understand is with this particular planet, this is a hot world. It's actually closer to its star than Mercury is to our sun. And so we're not looking at liquid water here, but we're looking instead at sort of steam, water vapor.
Yes, this is an exoplanet. It's about the size of Jupiter, about half the mass of Jupiter. It orbits around a sun-like star, but it does it every about 3.5 days. Right. So it's extremely hot, extremely close in, nothing like our solar system planets. But that's okay, because what we're seeing is, again, the first exoplanet data from Webb, and this is just the beginning. We're going to start pushing down to further smaller planets and being able to take measurements just like this with the NIRS instrument that was built by the Canadian Space Agency, but also there's three other science instruments that will add to our knowledge in the infrared, as well as direct imaging modes along with the transit method. So there's a lot more to come.
And I guess one thing we should mention is not only are we going to be looking at planets that are more like the Earth in the future, but we'll also be looking at planets in our own solar system.
Absolutely, yes. We're going to have exciting data from planets in our solar system, from Mars outward, as well as asteroids and comets. So stay tuned for a lot more to come.
Thank you so much, Nicole. Thank you so much for telling us about the spectrum, and I'll be seeing you later on today. So we have 3 more big image reveals, and with that, new and more exciting science. But first, let's take a look back at the journey that brought us to this moment. Celebrations like this one are only possible with years of hard work from a cast of thousands. When a new mission is being built, even the most enthusiastic space fans only get to see dramatic moments in its life cycle, the news and images that come out in updates and press releases. But that doesn't really give you the sense of the huge effort that goes on behind the scenes every day. The plans, schedules, and organization to keep everything moving forward really happens, for the most part, out of people's gaze. Webb started as an idea that took root at NASA Goddard. It grew first into planning teams, research projects, schematics, requirements. Then it began the long journey to become real with the development of new technologies, cutting-edge engineering, and finally fabrication, putting it all together. Let's take a brief look back at the visionary journey to how we all got here today.
So today was the final closeout of the purge.
Okay, guys, I can hear Rupa,
It's
but
a pretty emotional moment to be in there and actually, you know, closing it up for the very last time, right? You know, you're the last one to touch this, and so that was the final operation. And once that fitting is closed out, there's no more touching of the vehicle. We're ready for launch.
The James Webb Space Telescope. Born from the desires of astronomers, achieved with newly invented technology, is the culmination of 20 years of work. Humanity has unlimited questions about our universe. Engineering a way to investigate them requires enormous creativity.
Webb has been a trade-off between engineering performance, what the astronomers want, risk. In fact, when we started 20 years ago, we were actually looking at an 8-meter telescope.
Developing the most sensitive instruments. And testing, and more testing.
And so you don't want to build one that's just incrementally better than what you've got. Because if that's the case, you would just observe longer on the telescope that you already got. And so every time NASA builds a new astrophysics mission, a new telescope, it needs to be way more sensitive, way more capable than anything we've ever built before.
We all got together in that conference room and we played real time as the images came down from the spacecraft, the very first diffraction limited images ever obtained with Webb. And what we collectively saw as a group was the highest resolution infrared image taken from space ever.
If you're just joining us, I'm Michelle Thaler at NASA's Goddard Space Flight Center, and you are watching live coverage of the release of the first science images from the James Webb Space Telescope. So it's appropriate now that I send the broadcast to our colleagues and friends at the Space Telescope Science Institute in Baltimore. That's the scientific nerd center of the entire Webb mission. So hello, good morning, Alex. The show is yours.
Hey, Michelle. Welcome to the Space Telescope Science Institute. I'm Alex Lockwood, and I'm here with Carl Gordon, who is an astronomer and one of the key people in delivering the images that you're going to see here today. But actually, before we get into the amazing images, we're going to talk a little bit about where we are. We're standing here outside of the Mission Operations Center, which is the key central hub for Webb. For the past 6 months, scientists and engineers have been working 24/7 since they took control of the telescope 30 minutes after launch to prepare for today and for the amazing science to come. Through all of the major deployments, focusing, aligning the telescope, and calibrating those 4 amazing science instruments, it was all done in this building. And from here on out, we'll have daily communications with the telescope, including sending commands and downloading data with the help of the Deep Space Network. In addition to mission operations, we are also the home of science operations. Well, what does that mean? Every year, we solicit proposals from astronomers across the country and the world for what they would like to look at with Webb. Then we hold a rigorous selection process to select the ideas that will best utilize Webb to study and understand our universe. When the data come down and astronomers analyze their results, we are the lucky ones who get to share that data and those amazing science results with you. And we knew that today was going to be so exciting with the first images, so we've actually been preparing for years. Here is Klaus Pontoppidan, project scientist for Webb and the technical lead for the first images,
it's been a years
to tell you
process.
about the process of the past few years of selecting
my first
the
email
targets.
related to the first images was back from 2016. So back then, a committee was created, and this committee was charged with coming up with a long list of targets for the first images. And the reason for that is that the observatory can't see the entire sky at any given time. And this is because you want to avoid the mirror seeing direct sunlight to keep it cold. And it actually had to be quite a long list. We ended up with about 70 targets, from which we had to select only a handful. What would create the most beautiful images, what would highlight the instruments, the different 4 science instruments for Webb, and what would highlight the 4 major science themes for Webb. And it's a celebration as well of the beginning of science observations.
And we knew that selecting the images was just the beginning, that we would need a trained eye to take these exquisite data and pull out the beauty and the science potential. So here's Jody Pasquale and Elisa Pagan to tell you about how they processed these beautiful images.
We're basically translating light that we can't see into light that we can see by applying color like red, green, and blue to the different filters that we have from Webb. And the reason we want to color the images is because there's actually more that you can get, more information that you can get from the image if you see it in color.
So it's a matter of picking and choosing filters and colors that enhance the details and the structure in the image itself.
The shortest wavelengths of infrared light and assign those blue colors, and then move our way down to green and red as we go to longer and longer wavelengths.
And then we additively combine those together to get our full color image.
But there is a lot of aesthetics that are involved in this. Painstakingly going through and cleaning these images up with an attention to detail, a level of detail like at the pixel level in every image.
So when I'm working on the astronomical data, it is this sort of marriage between art and science. When you're choosing colors for the filters, you really are trying to show the different details and the processes that are happening in the astronomical images. But at the end of the day, you want it to be very compelling. You want it to be very beautiful because space is beautiful.
And after those images were processed, there was a select few of us, very lucky few of us, who got to see the first images. And now, we are ready to see Webb's first image of a star dying, a planetary nebula called the Southern Ring. Let's do it.
Oof.
Wow, wow. This near-infrared image is, wow, the detail. Oh. Wow, okay, well, here we are. We have a near-infrared image on our left, or on maybe your right. And here on the right, we have a near-infrared image. And so I'm here with Carl, our astronomer specialist. Can you tell us what we're looking at in these images?
So this is a planetary nebula. It's caused by a dying star that has expelled a large fraction of its mass over in successive waves.
Okay, so we actually see those waves in these images.
Yes.
Wow, wow. And so there's a lot of structure. Can you tell us a little more detail about what we're looking? Maybe start with this one on the left.
Yeah. So in the NIRCam image, you see this kind of bubbly, almost foamy appearance throughout the whole nebula with some very structured shells. And this foaminess is showing up in orange mainly. And this is due to the molecular hydrogen that's newly formed in the expansion, just lighting up the gas and dust of this nebula. And then as we move inward, you see this kind of very blue haze in the inner region. And this is actually due to very hot ionized gas that emits well in the blue that's heated by the core, the leftover very hot core of this star.
And what about these like rays that I'm seeing in this image?
Right, so there's also rays in the outer regions that you can kind of see, and these are holes in the inner nebula that are actually allowing the central star's light to come out and kind of light it up like patchy clouds with the sun shining through.
Wow. Oh, yeah, that's what it looks like. That's so cool. So you're actually a mid-infrared astronomer, which is different than near-infrared. And so what can you tell us about the details in this mid-infrared image?
So it looks quite different in color, partly because we're seeing different kinds of physics going on here. So we're actually seeing in the blue, you see a lot of blue. The blue is actually due to hydrocarbon grains that are emitting very strongly in the blue for Miri. And they show the very similar structures to what we see in orange and NIRCam because the molecular hydrocarbon actually forms on the surface of dust grains. And so again, as we move inward, we see that the inner region is again hot ionized gas, but now it glows red because that's where it emits the strongest for Miri wavelengths.
Okay.
And then as we go into the center, we see kind of the surprise for us, which is we knew this was a binary star, but we effectively didn't really see much of the actual star that produced the nebula. But now in Miri, this star glows red because it has dust around it. So in Miri, we got to see both stars very clearly.
Yeah, you can't see it in the first image really, but there's two stars there. So that's a fun surprise. And I think that there's another little Easter egg you want to tell us about?
Yeah, so this was, the Easter egg is this kind of narrow filament up in the top that's radially aligned. You can kind of see it very clearly in the Miri image. It shows up as this blue structure, and it points very much to the central sources. So I thought, oh, this must just be a density enhancement in the outer nebula. I thought that very, very strongly, but other people on the team were like, no, it's a background edge-on galaxy. Well, I made a bet that said, no, it's part of the nebula. By the way, I lost the bet because then we looked more carefully at both the NIRCam and Miri images, and it's very clearly an edge-on galaxy with a dust lane and a bulge. So I lost the bet.
Well, you lost the bet, but you got these gorgeous images, so I think it's a win for everybody. Anything else you'd like to say today?
I can't wait to see where we go from here.
Oh, neither can I. All right. Thanks so much. Back to you, Michelle.
Thank you, Alex and Carl. And I have to say that image is absolutely spectacular. So as you know, people from all over the world are watching us today and joining in our excitement as we release Webb's first science images. We've been checking in with our colleagues in Europe and Canada throughout the program, but we also want to take a moment to include the people at the so many viewing parties scattered around the world like stars in the night sky. So let's check in with some of them now. First, we go all the way to Perth, Australia. Do we have a signal from Perth? I guess nothing from Perth right now. Maybe we have some of our other feeds. We're going to check in with them right now. Do we have Winnipeg, Canada? Oh, there it is. There's Australia. There's Perth. Hey, waving to Perth, Australia. Thank you so much for joining us today. And next we're going to Winnipeg, Canada. Hello, Winnipeg. At a planetarium. Everybody's enjoying the show, I hope. Okay, Dayton, Ohio. Everybody's watching on the, there we go, Dayton, Ohio. Hello, everybody, Dayton. Nice to have you here with us. There we go, yes. Hey, Dayton. Hey, they're jumping up and down. Hi. Okay, all the way Bangalore, India. Bangalore. Hello to Bangalore, India. Hey. That's absolutely wonderful. Hey. Okay, so I hope you enjoy the rest of the images we're releasing. Okay, of course, NASA's family extends all over the country. The team at JPL in Pasadena, California, they're on site to celebrate with us. So hello, JPL! Some of my favorite people in the world. Hey, hello! And then I think the last place we're going to right now is Northrop Grumman, one of our major contractors. Hello, Northrop Grumman! Oh, hey, all right! Yay! Nice to see you, Northrop Grumman. All right, now there's also a big watch party right here on the NASA Goddard campus. Many of these people have worked on the mission itself, and we also have top NASA leadership and representatives from our government. So hello! Hello, watch party at Goddard. Yay! Okay, wonderful. So, I mean, at NASA, we are so fortunate to have all of these friends and colleagues around the globe. A major partner in the Webb mission is the European Space Agency. ESA contributions have been essential to so many aspects of this project, including Webb's spectacular launch on the Ariane 5 rocket last December. I'm very pleased to turn over the show for a few minutes to Katie Haswell. She's joining me from the European Space Operations Center in Darmstadt, Germany. Hello, Katie. Good afternoon.
Thanks, Michelle. Thank you, Michelle, and welcome to Germany. We're at the European Space Agency.
I'm still getting all kinds of IFB from lots of
center. It's where the teams effectively fly the satellites. They're a little bit of a cross between air traffic controllers and pilots. We have lots of different control rooms here. This is the main control room, and as you can see today, it's not in use, so we've been lucky enough to move in here for today. I have two very special experts with me, both scientists from the European Space Agency. Giovanna Giardino is a near-spec scientist. Giovanna has been working on that for many years and lots to tell us about that. And Mark McCaughrean is a special advisor for space, for science and exploration. These two guys have been working on the Webb Space Telescope for a long time, so we're very grateful to have you with us. Thanks, folks.
Great to be here.
Pleasure. We are excited to reveal our image with you. But before we do that, we thought we'd give you a little bit of background, because we've come here today because these guys were the first ones to pick up the signal during the Webb launch, when Webb first launched. They run a system called S-Track, which is NASA's deep space tracking system, and they were listening out when Webb called home. And the controllers here have been looking after a whole very, very impressive list of missions since 1968. ESA has played a very, very important role during the for the Webb Space Telescope. They provided the launch on board the awesome Ariane 5 launch vehicle from the Guiana Space Center. The atmosphere in the Mission Control Center was electric, I can tell you. I was there. They've also provided people. We have 15 ESA scientists working at Space Telescope in Baltimore, and also they have provided the infrared spectrograph, the near-infrared spectrograph, and also half of the MIRI instrument, which is the mid-infrared instrument. Let's take a look at those now.
Webb's 4 scientific instruments include NIRSPEC, the near-infrared spectrograph led by ESA. NIRSPEC splits near-infrared light from astronomical objects into its components. Like a barcode, this will help scientists understand the physics of the objects they're observing, from their temperature to atomic makeup. NIRSPEC can observe parts of an object or the sky using an image slicer and an array of microscopic shutters. Webb's integrated science instrument module, located behind the main mirror, also contains MIRI, a mid-infrared camera and spectrograph. Seen here during testing, MIRI's been developed by a partnership between Europe and the US. MIRI detects mid-infrared light from planets, stars and galaxies. It can analyse molecules to help us deduce what astronomical objects are made of and peer into clouds of gas and dust where stars and planets are born. Together, these instruments will help Webb detect and analyse light from the very dawn of time, revealing the universe as never before.
So let's get ready to reveal our image. And remember that one of Webb's jobs is to find out about galaxies, more about the galaxies, but also to help us to understand how they change. And this image is going to be very, very useful for that. Let's reveal it now. There it is. It's called Stephan's Quintet, and it's wondrous. Giovanna, what are we looking at?
Yes, like it's a quintet, so we are looking at 5 galaxies. Galaxies are this giant structure that, as we've seen, we see everywhere around us in the universe. They contain from million to 100 billions of stars, and in fact we live in one of them, the Milky Way. And here we see 5 of them. This is a closer galaxy in the foreground, and these 4 are at a distance of about 300 million light years from us, and are locked in a close interaction, a sort of cosmic dance driven by the gravitational force. you can see here these two in a process of merging within each other. This is a very important image and an area to study because it really shows the type of interaction that drives the evolution of galaxies. That's the mechanism of galaxies' growth.
I love this image of the cosmic dance moving through each other. Mark, there's a lot going on, though, in this image, isn't there?
There is. So this is a near-infrared image and a mid-infrared image combined. And when we zoom in on the left-hand side here, we see this foreground galaxy. We see lots of individual stars in there, actually resolved as point sources, which is remarkable. And then as we pan across, we actually see the galaxies in the merging galaxies. We now see gas and dust, which is being heated up in the collision between those galaxies. And that's a place where new stars are being born today. So we're actually seeing the process of creation of new stars in this region. And then when we look in the background here, we see not only the galaxies at 300 million light years, but also stars in our own galaxy. These snowflake structures that you see here, those are nearby stars, but in the corner and around the edges we see galaxies which are much, much more distant, much further away. So similar in some sense to the ones that we saw earlier on in that deep field. And so this image actually takes us from the nearby galaxy, our own Milky Way, through these galaxies which are evolving today all the way to the distant universe. And in a way it captures cosmic evolution of galaxies over those 13.8 billion years.
So we have another image, don't we, that we can look at?
So if we strip away the near-infrared view there of the stars predominantly, now in the mid-infrared with MIRI alone, we see mostly gas and dust. So we see the same galaxies again, the two merging, and then we also see something very interesting up at the top here, because this top galaxy has something new and bright in the middle of it. And Giovanna, tell us what that is.
Yeah, that's an active black hole. We cannot see the black hole itself, but we see the material swirling around, being swallowed by these sort of cosmic monsters, and this gas gets heated to extremely high temperature as it falls onto the black hole, and it becomes very bright. In fact, this is how shiny is the galaxy. Here we see luminosity that are 40 billion times the luminosity of our suns. It's really, really bright. And with NIRSpec, we can zoom into this area, and we have this technology that allows us to take thousands of images at different wavelength channels, so see this distribution of the gas, what's going on in the gas in different regions of this core area, and understand the composition of the gas, the velocities, the temperature. So that's very important to understand the physics.
So it's giving us so much information, and it just shows the power of this telescope. Mark, this is just the beginning, though, isn't it?
I think that's a very important takeaway from today. You know, these are like pictures just taken over a period of 5 days, and every 5 days we're getting more data, which will contribute more in that direction. It's a culmination of decades of work, but it's just the beginning of decades. And you know what we've seen today with these images is essentially that we're ready now. This telescope is working fantastically well, and you know, to borrow a phrase from a famous rock musician, you know, we're ready to turn this telescope up to 11. It really is time. It's fantastic.
Thank you very much indeed, both of you. Back to you, Michelle.
Thanks, Katie. It is so great to have you and your colleagues with us on this historic day. So before we get to the fifth and final image reveal of the day, it cannot be said enough that an achievement like the James Webb Space Telescope is something bigger than any one of us. It's bigger than any organization, any country. This truly takes a planet. Webb belongs to all of us, and starting today, the discoveries start and they're not going to stop. This is just the beginning. We've said several times throughout the broadcast that the Webb mission is about people, and during the construction of the Great Telescope, people started to see themselves in it, literally. Day after day, people visited the observation window at NASA Goddard, and looking through the glass, they snapped selfies of themselves reflected in the gigantic golden mirror. These photos are actual reflections of the enormous human investment and the emotional commitment that brought this mission to life. And now, years later, that mission is finally collecting light from the earliest days of the universe, all the way to worlds in our own solar system. It's the same mirror that reflected the many faces who see themselves as part of the journey to understand our shared origins. Let's stop for a moment and appreciate the people behind Webb. Okay, it's time now for the last image to be revealed. Here we go. So Amber Strawn is Webb's deputy project scientist. She's here with me today to share the final big reveal of the day. So Amber, it is so good to see you. How are you feeling?
Oh, so great, so exciting. What a great day this is.
Yes, so one of the things that we're going to do is before we get to the final image, the James Webb Space Telescope has taken us all over the universe today. So let's do a quick review of where we've been so far. So Jane Rigby got us rolling today with an extraordinary new deep field image, showing us one of the farthest views of the universe ever.
Yeah, this image really does demonstrate that JWST can do exactly what we've designed it to do.
Yes. And the Canadian Space Agency then took us to the massive planet WASP 96b, where the team has detected evidence of atmospheric water.
And here again, we're seeing the incredible efficiency of this observatory. We're able to do these kind of measurements in a fraction of the time that we're able to before.
And then we zipped up the road from NASA Goddard to the Space Telescope Science Institute, where Alex and Carl showed us the exquisite Southern Ring Nebula, a mixing bowl of stellar matter around a pair of dying stars.
Yeah, and I'm just blown away by the level of detail we can see, like in the outer part of this nebula. It's incredible.
Wow. Okay. After that, I was off to Germany, where the European Space Agency wowed us with pictures of galaxies interacting and mixing together.
Right, and this image, again, it's incredible because it's showing us one of these fundamental processes of the universe, how galaxies merge together, and we're able to learn about these processes in a brand new way.
So the Webb team has a lot to cheer about right now. So across the campus, there's this big watch party, and we can feel the excitement all the way from over here. So let's join that celebration now. We're back with Senior Project Scientist John Mather, along with the head of NASA's Science Mission Directorate, Thomas Zurbuchen. Hello.
So, John, we looked around the world and we're the only ones with a cheerleading crew right over there. That's amazing. Look, you've been with this mission for decades. How do you feel today?
I am so thrilled and so relieved. This was so hard, and it took so long. It's just impossible to convey how hard it really was. That we risked so much to say we're going to go do this, and it's so near impossible, but we did it.
Yeah, there are thousands of ways this can go wrong.
Yes.
Many of them, we worried about and frankly feared even after launch. I have to tell you, I was really, really nervous, and it's almost like athletics for me. You always get to know the team when they're on the field, and on the field they were right after this launch, and they were perfect.
They absolutely were, and I really wasn't worried, but maybe I should have been.
Yeah, that's difference between the two of us. I always worry. I always tell everybody I'm paid to worry, frankly, and that's good. What we want to do, though, is just really thank the team again. Of course, we heard Bill and Scott and Greg talking about the team that is there. I think what's also important is to recognize that Bernie is sitting there, who was the first manager. I was sitting there. Could you stand up? And I want to mention that Phil Sabelhaus, who was a manager also during that time, is no longer with us, but his heart is with us today.
Yeah.
I have to tell you, John, after each one of these milestones, I called a lot of people. I called Bernie, for example, and I called people at my job and people who are administrators, because there's many of them. And I just wonder how you feel about the team. Just give you the word here.
I am just so thrilled that we had a privilege to assemble such a brilliant team. We drew from the best of the best, and here we are. So my extreme deep thanks go to all the people who built that team, not only to Bernie, who started us and helped us build up all the technology, to Phil, who made sure we would have a plan, and then when we didn't have quite enough money, to Bill, who pulled it all together and made it get all the way to the end. I am so thrilled that we had so much talent to draw on. And here we are, we have the support of the country and the world to take on this immense challenge.
You know what I'm most excited about? There's tens of thousands of scientists, and frankly, some of them just got born, or not even born, who are benefiting from this amazing telescope, because it will be with us for decades.
It will be.
That?
It took us about 25 years to get here, since 1995, and we have at least 25 to go, I hope.
So look, we are in a sense of these images, the art that is out there in the sky, revealed for the first time. We're thinking of the team and we're thanking them. John, thanks to you, thanks to all of you, and back to Michelle.
Thank you so much, Thomas. And this entire collection continues to just absolutely astound me. Okay, Amber, so here it is. Can you walk us through the final image reveal?
Absolutely. Here we go.
The last image is, wow, look at that. So Amber, can you tell us a bit about what we're seeing here?
Of course. This stunning vista of the cosmic cliffs of the Carina Nebula reveals new details about this vast stellar nursery. Today, for the first time, we're seeing brand new stars that were previously completely hidden from our view.
There's something you want to point out here?
Absolutely. So honestly, it took me a while to even figure out what to call out in this image. There's just so much going on here. It's so beautiful. One thing that really stands out to me is you sort of get this sense of depth and texture from this new data. There's a lot going on. To call out a few specifics, first of all, in general, the Carina Nebula is a nearby star-forming region within our own Milky Way galaxy, about 7,600 light years away. And in this view, we see some great examples, first of all, of hundreds of new stars that we've never seen before. We see examples of bubbles and cavities and jets that are being blown out by these newborn stars. We even see some galaxies sort of lurking in the background up here. We see examples of structures that, honestly, we don't even know what they are. Like, what's going on here? The data is just so rich.
And there's something really special about the infrared. Infrared can actually see deeper into these star-forming regions.
Absolutely. That's one of the great things about infrared, is it really does reveal what's going on here in a really cosmic sense. And in general, what's happening in sort of this overall landscape is we have these gigantic, hot, young stars up here to the top of this rim, and the radiation and stellar winds from those stars is sort of pushing down and running into all of this. This is gas and dust, and of course we know that gas and dust is great raw material for newborn stars and baby planets. But there's a flip side to this story, and also a little bit of a mystery, because these same processes can serve to sort of erode away this material and stop star formation. So we have this sort of delicate balance going on of new stars being formed, but at the same time the star formation is being halted. And for me, when I see an image like this, I can't help but think about scale. You know, every dot of light we see here is an individual star, not unlike our sun, and many of these likely also have planets. And it just reminds me that, you know, our sun and our planets, and ultimately us, were formed out of the same kind of stuff that we see here. We humans really are connected to the universe. We're made of the same stuff in this beautiful landscape.
And actually, the Carina Nebula was one of my favorite images from Hubble. So Hubble looked at this as well, right?
Absolutely, yeah. The Hubble image of this is also spectacular. We saw it in a different kind of light when Hubble took an image of this particular nebula. And then you can see amazing things with Hubble, but when we zoom in to this new image, we're able to see so much more detail. And of course, all of us, you know, I grew up on Hubble, and all of us love Hubble. And I'm so excited to see what these two amazing observatories are able to do really in tandem with each other.
Thank you so much. And again, congratulations. It's been a pleasure to be working on this with you. I'm just amazed by what's been going on.
I am too. Thank you.
So as we're wrapping up, one of the things that I really have to say is the journey that we've been going on is so very dramatic for me. So we've gone all the way from the birth of stars, and we have all the way from the distant galaxies to the birth of stars. This is where we all began. This was the whole point of the James Webb Space Telescope, to figure out our origins from the very, very early days of the universe to star and planet formation very nearby. So right now I'm very honored to have our last special guest. This is the administrator of NASA, Bill Nelson. An honor to be with you, sir.
Hey, what a pleasure. What a banner day. It's clear that Webb represents the best of NASA. It maintains our ability to propel us forward for science, for risk-taking, for inspiration. And we don't want to ever stop exploring the heavens, nor stop daring to take another step forward for humanity. In the words of the famous Carl Sagan, somewhere something incredible is waiting to be known. I think those words are becoming reality.
Absolutely.
Thanks, Michelle.
An honor to have you here. Thank you very much. Wow. So this is a celebration for all humanity. If you've ever looked up at the night sky and wonder, whoever you are, wherever you are, this is your telescope. And we also salute the thousands of people who have dedicated part of their lives to making Webb a reality. I also want to give a big shout out for the superb media team who's helped bring Webb's story to the world. This broadcast is a joint effort of the superstar producers, animators, and social media specialists at the Canadian Space Agency, ESA, NASA, and especially the Goddard Space Flight Center. Webb captures light in distant colors that the eye can't see, and you've actually made this visible to the world. So finally, if you go to nasa.gov/web-first-images, you can download all of the images and data we've just shown in full resolution, and check back often. From now on, we share new discoveries from exciting new destinations around the universe. July 12th, 2022 marks a huge day for science, and it's only just the beginning. For everyone at CSA, ESA, and NASA, I'm so very pleased you could join us. I'm Michelle Fowler. Go Webb.